This tutorial is about rendering regular, concrete paver and steppe grass. But before we make the materials, let's have a look at the factors we need to take into account, such as color, density, length and bending. The color of grass blades depends on the type of grass and the ground's dryness. The density can range from 40,000 blades per square meter for a human-made lawn to only 500 blades for steppe grass, and with concrete pavers, there are regions without any grass at all. Also, the length of the grass depends very much on whether it's a human-made lawn or naturally growing wild grass. The longer the grass blades and the lesser their stiffness, the bending location and bending radius changes. Let's look at the basic rendered examples. Regular grass, concrete paver grass, and steppe grass. Once you understood how these materials work, you can easily modify them for other outdoor rendering purposes. Open Maxwell Studio and load a standard beginner layout using the Windows menu. Drag a 1x1 polygon plane from the library to the viewport and scale it up to 6 meters. Import the crash barrier OBJ file into the scene. With models done by other people, you may notice some polygon smoothing errors. Change the polygon smoothing angle to 30 in the Appearance tab and click Reset to apply the setting. Rotate and position the crash barrier, right-click in the object lister to clone it, then position and rotate it also. Open a metal material with scratches and apply it to the crash barriers. You will get an alert message, so what is that telling you? When a material's texture mapping method is set to meters and uses real-world texture dimensions, the object's UV set projectors must change accordingly. Now we want to set up a view that is clipping the plane's edges, so right-click in the Attributes tab and create a new camera, and don't forget to change your viewport. To set up the lens, first change the render resolution to HD format. Using a long lens eliminates perspective distortion, and a low f-stop provides a nice depth of field. Instead of pushing the lighting to absurd values, simply adjust the shutter speed and ISO to change the scene's brightness, just like you would using a physical camera. Set the camera location and focus target numerically to keep the view perfectly centered and to clip the plane's edges. You can also view and change your cameras in the perspective viewport. Change the environment from none to image-based lighting and load a small HDR image to light your scene. Activate the sky in the viewport to make the environment visible. Then adjust the sun's position by changing the HDR image offsets. Now that we have a suitable scene, camera and lighting, right-click in the Materials list and select New Custom. Rename the material, add a layer and rename both Blades and Ground. The blade texture must be in UV channel 0 and the ground texture in channel 1. I'm putting this in the layers names just as a reminder for beginners. Load a fresh grass blade texture into the blade layer's reflectance 0 texture slot and lower the roughness. Load a mostly green ground texture into the ground layer's reflectance 0 texture slot and increase the saturation, then change its UV channel to 1. Finally, set the map to absolute scale and 1.8 by 1.8 meters, which is what the texture represents in the real world. Drag the material onto the plane and OK the absolute scale alert message. Set the material's preview option to the ground texture so you can see it in the viewport. Go to Geometry in Object Parameters. Choose Cubic as projection method for both UV channels 0 and 1, then click Normalize so the projectors know you're using them with a real scale material. You can delete the third projector because we don't use it. Now create a new grass modifier in the Modifiers tab and select the grass regular material. Change the grass modifier settings as shown. Don't be surprised, but the density of lawn is in the ballpark of 25 to 40,000 grass blades per square meter. You can also specify a cut-off height to mimic lawn mower cutting. Start the interactive renderer to preview the finished material in the scene's context. And if you're happy with the result, start a full-size final rendering. Right-click in the materials list and select Clone Material to make a duplicate. Then rename the material. On the ground layer, replace the ground texture with a more patchy grass texture and change the saturation and hue. Add a new layer and rename it. Then load a concrete diffuse texture and reduce its contrast. Set its mapping to absolute scale and 1.5 by 2 meters, which is what the texture represents in the real world. Then change the UV channel to 1 like the ground. To bump map the edges of the concrete pavers, you need to paint a texture in Illustrator or Photoshop. Load the texture and set the mapping to absolute scale and 1.8 by 1.8 meters. Then change the UV channel to 1 like the ground and rotate the texture 45 degrees. Load a concrete roughness texture into the roughness slot, invert and brighten it. Then set its scale and channel to match the concrete diffuse texture. To clip the concrete pavers with an opacity map, you'll need to paint a texture in Illustrator or Photoshop. Load it and set its mapping parameters to match the bump texture. Drag the new material onto the plane and OK the alert message. You may want to change the material's preview to check its textures in the viewport. On the Modifier tab, change the grass modifier's material to the one we just created. You don't want grass growing through the concrete, so you need a plant distribution map. Paint a texture in Illustrator or Photoshop and make the pavers a bit larger than those in the opacity texture to leave a bit of a gap between concrete and grass. Again, don't forget to set the mapping parameters and UV channel to match the ground texture. To vary the length of the grass and make it look a bit driven over in some areas, you can load a grayscale texture as a length map. Start the interactive renderer to preview the material in the scene's context. Now we could start a full-size final rendering, but to make things more interesting, let's grow some daisies. From the Object menu, load two plants as MXS references and hide them. MXS references are self-contained scene files with nothing but objects and their materials ready to render. Select the plane and create a new scatter modifier in the Modifiers tab. Then specify one of the daisy MXS references as object to be scattered. Change the density to a low number and load the plant distribution texture, like for the grass modifier, so that no daisies are growing through the concrete. Set the rotation to 360 degrees and variation to 100% so that the orientation of all scattered daisy MXS references is nicely randomized. Right-click and copy-paste the scatter modifier, then select the other daisy MXS reference you loaded. Change the plant density and don't forget to change the random seed. Otherwise, all daisies would appear in the same location on top of each other. Start the interactive renderer to preview the finished material in the scene's context. And if you're happy with the result, start a full-size final rendering. Right-click in the materials list and select Clone Material to make a duplicate. Then rename the material. Replace the blade texture on the blade layer with a more wilted version, and replace the ground texture on the ground layer with something more patchy. Then change the brightness. Drag the material onto the plane and disable the existing modifiers. Now create a new grass modifier in the Modifiers tab and select the steppe grass material. Change the grass modifier settings as shown. We need a much lower density, a much longer and more bendy grass, so to speak. Like in the previous grass material, we are using a length map to vary the blade's length in a controlled way instead of only randomizing it. Start the interactive renderer to preview the material in the scene's context. Now we could start a full-size final rendering, but to make things a bit more steppe-like, let's grow some downy brome and silver hairgrass plants. Like in the previous example, we are loading the plants as MXS references, then we scatter them sparsely with a scatter modifier for each plant. Start the interactive renderer to preview the scattered plants in the scene's context. And if you're happy with the result, start a full-size final rendering. And now it's your turn. Thank you for watching and listening.